This is the ROS Developers Podcast, episode 116.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS Developers, and welcome to the ROS Developers Podcast. The podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct, and today I would like to dedicate this episode to all the people around the world that are using ROS to develop autonomous robots that will move around us, in our streets, in our buildings, in our space, together with us, humans, while doing some useful tasks. So if you are working on this subject, then this episode is dedicated to you. Good job, tough guys. Then today we are going to learn about such an amazing company that has succeeded worldwide using robots in different situations, and we are going to learn especially about some of the projects that they are conducting in Tokyo, and how I got delivered also this bottle of water from a shop over here. Then we are going to learn about this in a minute, but before that, let me tell you about the courses that you can do at The Construct. So you know that The Construct is a company that is specialized in teaching you about how to program your robots with ROS, and we have some specific courses, very well done, based on practice. So you will be on the platform that we have created with all the learning material and practicing from minute one with simulated robots and also remote real robots. Those are robots that we have in Barcelona, and then you will connect to those robots from your location and program them, make them do some mistakes and some correct things. So you are going to be practicing from minute one. We are about to launch our masterclass, which is a 6 months program that brings you from zero to robotics developer, where we teach you all the subjects that you need in order to get a job into a robotics company as a robotics developer. Have a look at the link I will put here down on the show notes, and let me know if you are interested on this. I think it's a very good opportunity for you now. Now, let's go to the meat of this episode, and let me introduce you Tomohiko Furutani. Tomohiko-san is the manager of the AI Robot development section of SoftBank in Tokyo. Welcome to the podcast, Tomohiko-san.
Hi, this is Tomohiko Furutani. Nice to meet you, Ricardo-san, and all the audience here.
Okay, thank you very much. That's the second time that we meet.
Yeah,
but then
it was online. It was, yes.
No, but I also visited in 2018, and you were in some other offices here in Tokyo.
Yeah, it is close. It was in Shiodome,
okay.
Around a 10 minutes walk from here.
Okay. Yeah. I can see that this is more spectacular. It's even more filled with robots. I will put some pictures on the show notes also of the episode about this. Awesome the progression. But so I have seen on your description that you are the manager of the AI Robot development section of SoftBank. So what is the goal of this section, SoftBank?
Okay. Actually, the section name was recently updated to ROS SI promotion section.
Okay.
Yeah, this is to reflect the goal to promote integration of ROS-based solutions.
Okay. So now it's called ROS SI promotion section. What does it mean? What does it stand? SI.
SI is literally this is system integration.
Okay.
But I personally think this is more like a social integration. Yeah, robots need to be integrated in a social wide
environment.
Yes.
Okay. Okay. Great. Okay. Very good. And then, what is the relation of this section with SoftBank Robotics, the branch?
Yeah. So the SoftBank Robotics, SBR we call, is they oversee the robotics business whole in the SoftBank group.
Okay.
While we are a small development team in SoftBank Corp, this is telecom company and a core company of the SoftBank group.
Okay, I see. So the section, the SoftBank Robotics section, is the one that is in charge of business of robotics, right? And then we can say that within this there is the ROS SI promotion section, which is the one that develops or makes developments or makes research.
Yeah. Main goal is the R&D, research and development, and also we work with the internal and external. More of external parties like other companies and universities. Okay. Yeah, we cooperate with external power to make joint trial or joint experiments.
Okay. Like for example, the one of 7-Eleven that we just saw some minutes ago.
Yeah, actually, that is another project within SoftBank Corp. We are a big company, and
yes.
Yeah, many departments are doing robots. So
okay. So I'm not going to go more on that direction because maybe we are going to confuse the audience also with so many different parts, and that's not the case. So then, as a manager, so what is your role in this section?
So as a manager, my main work is to keep the budget, keep the supplies and going, and and build good relations with the internal and external parties. We have to be in good relation with the building management to make a big real environment experiment. So this is kind of my main part of the work. Yes.
Okay, and so let me see here about my question. So then the whole section as a task of the whole section is to develop products or to deliver research that may lead to products in the future.
Yeah, the latter.
Okay.
Yeah. So we deliver research. So we do R&D and the research will lead to products in the future, not today. Yes.
Okay.
Yeah.
Very good. And then so we are here in the area which is called the Takeshiba district of Tokyo. And why this area is special?
Actually, Ricardo-san has experienced a bit, but this area and this area's management or the building management is very open to new challenges, new technologies. So with their support, we made very advanced experiments possible.
Like for example, so now that you mentioned myself, so the one that I have been experiencing this morning that is awesome. I'm amazed. Is about a delivery robot that is actually working there, so you can go and do with your phone and make a request for delivery from a 7-Eleven store
yes.
That is in another floor of this building. How many floors has this building?
This has 39 floors.
And
yes.
now we are on the 27.
27, yes.
And the shop is
21st.
21st floor. And so we order through the mobile phone, and then we order some things, and then after some minutes, then the robot was knocking on the door. I mean, not knocking, but
not physically, but on my
the
phone. Yeah.
Exactly, on the phone, he's telling you, "I'm out the door, so you can come and go close." So I will put some video also about the reception of this. Unfortunately, I couldn't record the whole process of the robot coming to here because it's moving through general areas that is not allowed to record for some other people around there. But I recorded when we grabbed the material, and also when everything, the whole process is finished. So we can say, oh, thank you, robot, you can go. And then the robot goes, and we follow it. It went to the elevator, asked for the elevator came, then the robot gets in, and then it goes. And then we followed to the downstairs, and then when we arrived, the robot already self-charged itself. So was in the self-charging station waiting for the next. And that's so what I am super amazed of this is that is actually working. You know, it's a building that has many offices, many people around, moving all the time on different floors, and you can do this application on your phone. It's a web application, and then it works. So I'm amazed. So this is one of the. Sorry to take so much time describing this experience, but it was very cool because it worked. It worked out of the like a normal thing, like not like a prepared demo. It's a normal thing. And then this is one of the companies, 7-Eleven, with the ones that you are doing some. Sorry, not that question. This is why we are in this area, in this specific area of Tokyo, that you can do this kind of experiment, right?
Yeah, actually, we need support of the, the robot has to communicate, work with the elevator system to make it possible. And it needs, it has to be already implemented into the building. So it took, such a special area, special support of the building management and all the areas needed to make such application possible.
Yes, exactly. Because maybe one of the questions of the audience is that how is possible that the robot is calling the elevator? So some people do understand how because they know more, but some people of the audience, they don't know. So can you explain how this works?
Okay, so the building has some special elevator management system, and that can communicate through internet.
Okay.
So the robot has built-in LTE connection capability. So when the order is reached to the store, the store clerk will input it, will send it to the robot. Then the clerk packs some products like this to the robot. Then then start the order.
Yes.
Then once the robot starts running, and when it needs to ride the elevator, the robot communicates with the system, the elevator management system, through the internet, and then call the elevator and ride it and go to other floor.
Okay.
Yeah, like that. Yes.
So it's this kind of communication through the internet that is made between the robot and the elevator. It's not that the robot, because maybe some people will imagine that the robot has some arms and then he's pushing the buttons or something like that. It's not like that.
Not like that.
Yeah. So it's this internal communication, but this communication has to be embedded into the robot and the management system of the robot. And also the elevator has to have some modifications, right? So it's not any elevator in any building is working off the shelf.
Not off the shelf, but we actually when building was in construction, the system was already installed.
Oh, okay.
Actually, this is much cheaper way to implement such solution.
Yeah, of course.
Yeah, to make it, to implement it, already built elevator is quite, difficult and costly.
It's more costly. Yes. Yeah, I was talking to Matthew Festo from Open Robotics Singapore a few weeks ago, and then he was explaining me that there are some systems that you can include into your elevator if it already exists, your elevator, and you want your robot to communicate, but that is quite expensive. So it's quite expensive and also requires some expert people to come to the elevator and do all the jobs. So so okay, great. Yeah, and yeah. By the way, so the waters that we are here getting, yes, and the chocolate
Chocolate
this is
here.
for later. So they were delivered by this robot while doing this demo. So awesome! Thank you. Never felt better the water. Okay, great. Then, so we were talking about the Takeshiba district of Tokyo, and which is an area that is when you say that is special, it's open to new challenges. You mean in the terms of the norms of the rules of the it's like a regulation.
Yeah, kind of deregulation is included in the area.
Yeah. So like the major of the area, it's or the council of the area, so they allow to do those kind of experiments, right?
Of course, that there are restrictions, but it is a bit easier than other areas.
So it doesn't involve the politicians in this, to say, or the government of this area.
The government of this area is quite friendly on new challenges.
Okay, so they are supporting this kind.
Yes, that's supportive. Yes, in this area. Yes.
So, for example, I don't know if that's the case, but maybe they will be interested on doing autonomous cars around here, right?
Yeah.
And that's why, for example, you could do like 1 year and before you did those experiments with this mobile robot that was moving on the streets and detecting the traffic light, right? Can you tell us more about that experiment?
Yeah, okay. So last year we did the outdoor going delivery experiment, and it was it included the coordination with the signal system. Yes. In that demonstration, the robot communicates with the signal system.
What is a signal system?
Signal system, I mean the, when the robot detects the signal, traffic signal.
The traffic.
Okay, the traffic signal. Yes, the signal is general term.
General, yeah. So, okay.
So.
So it's detecting those traffic signals by cameras, right?
That is popular way of doing that, but in our case, we did not take the approach.
Okay.
Yeah. Actually, we took the more reliable way of using the communication.
Okay. So something similar to what with the elevator.
Yeah, exactly. Yes.
Okay. And how does it work? Please keep.
Yeah. So to make that work, we attached the small equipment to the signal pole on the pole, and that detects or receives the signal. Yeah. And what color it actually is right now, and sends it to the cloud through the internet.
To the internet.
Yes, and the robots also communicates to the server to the internet, and gets the real-time information of what color is the signal, traffic signal is right now.
I see. Yeah, and then it can decide when to cross or when to wait.
Yes, exactly. And this is, much more reliable than the computer vision approach because, so the crossing we tested is quite wide. So from the computer vision, the traffic signal is so small, tiny pixels. So this is difficult to detect, and it will be, it may be blocked by somebody or some car may come in front of it, and so we believe this is more reliable. The communications more reliable.
Yes. So in that case, with your solution, so let's clarify to the audience. The delivery robot that we experienced today, this is something that is running. Okay, so it's something that is there. I can go now order again, and the people here at your office can order again, and so this is like a robot that is actually working, has a job right? Is there that what we are talking now is an experiment?
Yes.
It's an experiment. So and then so how was this experiment? So what was the goal of this experiment?
Okay, so one goal of the experiment that was carried out last year was to demonstrate the reliability of the communication system to detect the signal, and also the importance of such a smart city implementation. Making these traffic signal accessible through internet is very essential part of the smart city environment, and it will be used by autonomous cars and robots, and this is a possibilities,
Yes,
so
exactly.
huge.
Yes, exactly. Yes, and that would be in another direction. Instead of using cameras to detect everything under all the conditions. And then, because you mentioned something very, very interesting, that is the camera of the robot can be occluded by a car. And it's quite easy because the car is very small. The robot is very small. So it's very easy that something gets into its view towards the traffic light, right? Yes. So in this case, we will be going into the direction of a smart cities proposal, right? Like there are a lot of elements in the city that are sharing their status, and then other systems, they can grab this information and take decisions based on that, right? Okay. And then, so that was the goal, to test this communication. And then the experiment consisted on what? Of delivering a package from one location to another, crossing the streets.
The demonstration, and main part of the demonstration was your delivery. Yes.
Delivery. Okay.
Yeah, just by our partner's suggestion. So last year's experiment was in partnership with the Sagawa Express, a logistics company, and they are doing a cold things delivery. So we attached a small refrigerator on the robot.
Nice.
And
to keep
tested.
it cool.
Yes.
To keep it cool. That's right.
Yeah.
So this robot was actually waiting on the traffic light, and then crossing autonomously.
Yeah.
And then reaching from one location to another, avoiding pedestrians and so on. Oh, okay, awesome. So was it a success?
Yeah, it was a success. Yes.
Anything that you can share with us? Any trouble? Any something interesting that you found that you didn't know?
Yeah, basically, it was a success. No trouble, no accident.
Yeah.
And actually,
But something that I'm talking just by curiosity. For example, I don't know. So the typical, when you put a robot on the outside, then a lot of kids, they come and they try to trick the robot, and then so sometimes the robot is able to solve, or I don't know, maybe for example here there is not a problem that is common in other countries, like for example in mine. I don't know if I'm from Spain, so I don't know if I would put a robot there, because the first thing that we think about is how to prevent people from stealing the goods in the inside. And in other countries, so I don't know, but maybe it's even worse, because they can steal even the robot. So
the whole robot?
Yes, of course.
Wow.
Yes. So that's a problem that you don't have here in Japan, because it's very secure. But in other countries, so this is happening. You get dropped the bicycle. You can drop the bicycle in Spain, for example, and in other countries also, or the motorbike even. So they take your motorbike completely. So a robot that is moving around there also could be. Have you thought about that?
Yeah, actually, it was experiment.
Yes.
So we did not care that much about security, so the delivery robot will be legalized in Japan next year.
Oh,
Yes, expected to debut in next April. So, and every company is expecting to go into the industry is thinking very keen on the security too, and actually the police is also concerned about the security too. So
is security in other terms, right? Is security in terms that the people doesn't get hurt by the robot?
doesn't get hurt is one thing, and also the robot is not used for the terror attack or sending bombs or that kind of thing is also concerned.
Oh, okay, yes, that's right, that's right. Oh yes, wow.
Yeah, so it's
big problems.
Yeah,
this-
it's
those one.
the problem, and it's becoming a real
Yeah.
problem.
Yeah, exactly, a real problem, exactly. Exactly, because you can put a package inside this and send to somewhere, and then it just goes and this. Okay, but I'm pretty sure we'll figure out a way of solving those things. I'm pretty sure, but I would be amazed. So the other day I was visiting, for example, Mujin. Robot.
Mujin.
Mujin, yes, and then they are on these packaging systems, and I saw their system for
The robot arm system,
yes,
they are very good.
coordinated also with the other robots.
AGV carrying robots.
Yes, carrying robots are awesome. And then I think that this is a reality right now in many companies. Also, I was visiting Reputa Robotics. Also, they are picking assistant, and they many systems already working systems, already working, not experiments. And then maybe this one about the delivery in the cities is actually something that is going to start to appear in reality.
Yes.
Not only. So you mentioned that in next year, 2023.
2023, yes.
So because we are recording this at the end of 2022, so and then it will be published in January of 2023. So it's on the 2023. So it's going to appear this delivery robot here in this area or extended area or.
Well, nationwide it is legal, but of course, not at once, of course.
Yeah.
Start from limited areas, of course, but everyone actually from government side and the enterprise side, they're both willing to implement. So we can expect to see actually running robots in Japan and
as delivery service.
Delivery service 2023.
Wow, awesome. Okay, please call me when you start doing these things, and then I would like to.
Okay. Actually,
I would like to see the deployment.
Yeah. Actually, SoftBank or SoftBank Robotics may not be the first thinking, but
just joking.
In
yes.
Japan,
I would like to be invited, but I know that's super complicated. And the last thing that they are going to be thinking is about inviting Ricardo. So they have a lot of other problems, more important. Okay, then let me see here about the question. So because I have to ask some of them, but still some missing. About this experiment about obeying traffic signal. So how many people was involved in the development of this test?
Well, for the development of the robot, our team is involved, and that's around 10 plus people were involved. And the software and the communication part was mainly led by him, this guy here.
Okay, so yes.
Yeah. Not like here. Okay.
Okay.
The software programming part was only managed by a few engineers. Yeah.
Okay. Then would it be possible to add your name in the podcast?
Mr. Kuramoto, wanna stay anonymous or
anonymous?
up to you.
Okay. Okay, we'll discuss.
I think I'm not going to talk so much.
Okay. We'll discuss later. So no problems. Then
If you have any questions about the development, you can ask me.
Okay.
Yeah, actually, yeah.
If you
That,
don't
that's
have
why
anything
I wanted
to do,
him to be
it's
here. So
very
yeah.
fun. I just wanted to see how the podcasts are recorded.
Okay,
I
okay.
listen to these series sometimes.
Oh, okay. Thank you very much. My honor then. Great. So what are the abilities of this delivery robot? What is capable of?
Delivery robot, the one we use outdoors.
Yes.
So again, as I said, it was equipped with small refrigerator and made the cold delivery possible. And other than that, this is kind of basic delivery robot, capable of equipped with 3D lidars. So SLAM based on 3D lidars and obstacle detection and slow down and stop. And yeah, so the listener of this podcast are quite familiar with such,
Yes, this technology is very the typical SLAM navigation solution, right?
Yes.
But it's for using SLAM in the outdoors, then it requires to have a map of the environment. So you made a map of the outside environment. Okay. A 3D map or a 2D map?
3D map.
3D.
And, yes, and we use the actual robot to make the map. We did not use the external MMS for mapping. We just use the robot.
The same robot that
Same robot.
afterwards will have to do it by itself, move by itself. Okay, so it created.
So remote controlled, and then we created the map and used it.
Okay. Great. And then, so all this on the outdoors delivery robot, it was working with ROS.
Yes, exactly. ROS 1. Actually, it was Meldic, right? Meldic, yes.
But the one that we have seen today, the indoors delivery robot, which is a product, let me call
product
it
one, yeah.
Yes. Then this one, so it's not using ROS, right?
It's not. Actually, this is developed by some external partner. So we did not access to actual the system.
Navigation system
Navigation
inside.
system.
Yes. Okay. Yes. Wanted to clarify to the audience because so the audience is ROS developers in general, but we know and we want to know that there are other possibilities there. So not everything has to be ROS if not necessary, and we want to know about other options, yes, to reevaluate it every time if ROS is the best option. We want to know about that. Then in this case, the actual robot for the indoor delivery robot was a robot that already exists and that is provided by another company, right?
Yes, that one. The one we saw before, it was provided by external company.
It's an external company, and then this robot has its own navigation system inside.
Sure.
That you cannot access. You cannot access to the topics, let's say, or you cannot control the wheels speed. You just provide as an external planner. You provide the goals to go, right, and the next actions to do.
Yeah.
Right. Okay. Great. Then let me see. So well, I have a question here about what is the current status of this outdoor delivery robot, because you told us that it's going to be running next year, 2023, but so can you tell us about something right now? About the current state?
Okay.
Something more?
Yeah. So the delivery robot will be legalized and will be available in Japan, but we are working on outdoor going robots, but more of doing it as a research project. And of course, according to the new rule, that decides the size of the road going robots. The 70 centimeter wide and 120 centimeter long, or that kind of limitations given. So we have developed some research platform to use and test it in the Tsukuba challenge. The Tsukuba challenge is,
that?
in a public road testing, kind of, this is challenge. This is open. This is a very,
It's
a competition.
It's a competition.
Yeah, it's a very popular, and so anyone can, participate. Open and competition that allows access to public road only in limited area.
Limited area, okay. And do the robot have some limitations in size? For example, can I use a car?
Of course, there's limitation of size.
The
of course,
size, right?
of course.
Okay. And so, what is the relation of this Tsukuba challenge with the outdoor robot? Yes. What is the relation between because you mentioned this Tsukuba challenge?
Yes.
So what is the relation?
So Tsukuba challenge is open and anyone can attend. So this is a very popular place to test new outdoor going robots.
I see.
So we took the chance to test our new this outdoor new platform.
Oh, okay. Yeah. So you are signaling to the screen that is showing this. It is not appearing on here, but I will put it. Also, I will edit this and include those images because I already have them here. Okay, so that's the new robot that you have developed as a research platform in order to test your new ideas, and then you use this Tsukuba challenge as a safe place where you can test on real roads.
Yeah.
Right. And then for the outdoor delivery robot, so which kind of self-driving abilities has your robot?
Okay, so we use the 3D LiDAR-based SLAM, and we use Altware for the control.
The one
Tier
that
4.
started from Tier 4.
Yes. Yeah, that's used for outdoor going robot.
Okay. And you mentioned before that you are doing the 3D the map of the environment, and then the localization is based on the localization system of AutoWare.
Yes.
Okay. And which sensors for the robot and what they are used for?
Okay. So the robot itself has quite many sensors, including 3D LiDARs, actually 3D LiDARs, and additional 2D LiDARs, and depth cameras, ultrasonic sensors, and so, and including IMU GNSS. But mainly the 3D LiDARs were used for getting the position. And the sensors used vary according to scenarios or places they go. For example, in our last year's experiment, it is so dense urban, so it is midst of high-rise buildings and going under the elevated expressway. So the GNSS GPS was not very effective. So we did not rely much on it.
Yeah. Okay. Yeah, but I know that AutoWare is possible to mix those signals, right? Yeah. The one of the local map and also of the local map. I mean the SLAM map, 3D map, and then also the GPS position. Yeah. Also, so you can mix it and fuse this information, right? Yes. So when one of them is not reliable, then you can provide more weight to the other. Actually, the Kalman filter that does it automatically. It does it automatically. So you are fusing those two signals.
Yes, fusing. But was it completely turned off or just made a weight? Was it?
It depends.
It depends on
the situation.
We just tested in a competition, so we had to modulate stuff, and we were just testing.
Okay. Not a big deal. Not a big point here. It was just by curiosity. Just wanted to know. Okay. Then you mentioned that your robot it's a sidewalk vehicle. What does it mean that a delivery robot is a sidewalk vehicle?
Well, being sidewalk vehicle means it is legally regarded as a pedestrian. So it has to, go to this sidewalk, and you have to cross the crossing according to these pedestrians traffic signal. And the speed is also limited to 6 kilometers per hour. So it is basically regarded as pedestrian.
Pedestrian, okay. Okay, I understand. I understand this definition. And yeah, that makes a lot of sense because based on how it is detected or assigned the position, then some rules apply or others, right?
Yeah,
that's the purpose of this. Okay, great. Then you have mentioned, we have mentioned here about indoor delivery robots, but also outdoor delivery robots. So based on your experience on both fields, so what can you tell us about the differences between one and the other?
Difference, okay. Well, as you saw in the actual working robots, indoor scenario, it is more likely that the one-by-one scenario, so one order and go and back should be sufficient, as long as we believe. But in outdoors, the things may different because the areas that one robot has to cover should be much wider. So it has to work with some kind of multi-location delivery should be required, and to make it kind of separated, secure, multiple cargo should be required.
Okay, yes, because you don't want to spend the whole time.
Yeah, the whole time just going back and forth.
Yeah, so you want to provide, you want to deliver to several people. Orders.
Sure.
Okay, never thought about this problem before. That's right. Okay, and for that you need to have separated areas for each one of the orders, right? Wow, that makes a lot more complicated because you require the space.
Space, and also some system and sort of application to to open it according to the order or the place or. So this is going to be complicated.
Yeah. So we as engineers, we never think about those things because we are concentrated on the problem of making the robot move around the streets and not crash against the people and find its way properly, right? And cross the roads, but never think about those practical problems because after you have solved this problem, the real problem that we try is to serve, to deliver, right? And then we never think about that. That's also, wow. Okay. Then, so what is going to be the next step of this development?
Next step, actually we are working on new platforms, to research platforms, and but to go further, to step into business area, maybe we can't do it by ourselves. We have to work with group companies or sometimes maybe external partners. There are many good players. They can make good robots. So maybe our choice may be to join forces together with such good players.
Okay, but then are you going to go into the direction of the outdoors delivery or into the indoors delivery, or both at the same time?
Actually, we focus more. For research and development project, we focus on the indoor first. And for that purpose, we already have our R&D platform. That's called Cuboid. As the name says, Cuboid shaped cube-shaped robot.
Okay, and that's your own platform, right?
Yeah, this is own and based on ROS.
Okay. Yes. So you are developing this, and what stage is this is able to deliver already?
Actually, it can deliver, and we have these cuboids are available for rent from our homepage.
Oh, Oh,
Yeah,
okay.
so yeah, it is maybe limited only to Japanese customers, but if someone's interested, then yeah, you can contact us for use it for research or development.
Also, okay. So then this Cuboid is an indoor robot
Indoor
that we
only.
have developed here. It is based on ROS. ROS 1 or ROS 2?
ROS 1 currently, and yeah, we are working on ROS 2 conversion.
Okay, and then so it has reached already the maturity as a product that people can rent. You
Rent it as a R&D platform.
as an RD.
Yes,
R&D
not a product.
Yeah, okay,
but
got it. Okay, so if for example, I want to, because that goes in the line that you explained before, that you need some other partners because you cannot do everything.
not
It's
alone.
not possible. Yeah, you cannot be experts in everything. Yes, and so then some other companies, maybe myself, I want to build a delivery service, indoor delivery service system, and then I can, not because I'm not based in Japan, but let's imagine I'm based in Japan, and then I want to rent this robot for doing my experiments, so I can see if it is feasible to build the business, which challenge I will have to solve. Like for example, you mentioned before the
you can contact us
you
too.
contact you. Okay. Then I will put a link on the show notes about directly to this page, so the audience that is interested, then they can go and contact you directly. I mean the project, the Cuboid project. Great. Then let me see. About your, now we know that there are not that a lot, but there are three ways that you can run your code. One is on board, another one is on the edge, and another one is on the cloud. Then those robots are running code in which one of those instances?
Mostly on board.
Mostly on board. And then you need another cloud device, right? That is that communicates for data, right? For example, for the elevator, you mentioned before that it needs to communicate. Is this information in the cloud also?
Actually, that part, the cloud part is, so the system we are currently developing, the cloud part is provided by, in the elevator's case, this is provided by Mitsubishi Electronics,
Okay.
not us.
Okay.
So our product or our development is mostly on board.
On board, I see. And you just communicate with whatever is the API.
Yeah,
and you
yes, external API
Yeah.
and works with,
Okay, I see. And so we have heard a lot about the 5G technology is going to revolutionize the robotics. So how do you think that 5G can help and improve this project of delivery robots?
So that's very important part, and that goes with the the legalized the external outdoor going delivery robot in Japan. But when these robots are legally runs on the street, they are required to be remotely controlled and monitored. So to make just one robot should be covered by LTE or traditional network, but if they are deployed so many,
I see.
then it is just impossible to cover just a traditional way. So the 5G implementation will be inevitable.
I see. Okay, very good point. Yes, I also never thought about it was one of my questions, always thinking about why so much on 5G. I know that 5G is reducing the latency, but really, do we need that so much reduced latency for these kind of robots if their speed is so limited and they are secure and so on? So maybe we don't need so much speed. But I never thought about the possibility of controlling hundreds of robots at the same time, you know. So yeah, now I can see, I understand the benefits of 5G. And yours is already is working with 5G. So the communication is performing 5G. The one that you used outdoor last year was
Well, the one we tested was based on LTE.
LTE.
Yeah, but actually we are a telecom company, so we have tested 5G unit too. And actually, just running one robot, we do not see much, improvement. But imagine when there are so many robots in one area.
Yeah.
And in that case, the 5G and the capacity will be, this is very crucial.
Yes.
Yeah.
Okay. Good point. Very good point. Okay. Then, so I have the question about if SoftBank thinking about creating a product for selling out of this prototype, but I think that you kind of answered, right? Because so far you are providing this as a research and development platform. Okay. Good. And it's working on ROS. So that means that the people who get this, they can interface with their own ROS programs and make everything work. Oh, great. Then, for example, several of them, they can be controlled, for example, by OpenRMF. The framework for fleet management.
Yeah.
Well, actually, OpenRMF can control. It doesn't care about that. Actually,
ROS 1 or ROS 2 or whatever.
Or any other API.
So as long as they can write an adapter.
Exactly. Yeah, that's right. Okay. Some stupid thing pop out of my mind,
Yeah, but we are also interested in OpenRMF.
Yes, I can see for the stickers on your.
I see. Yeah. Actually, we are interested in that. Yeah.
Are you applying this into any of your robots? Because the one that is here, the one that is delivering the product one that delivered out the goods, then this one was not running, and because there is no fleet, so there is only one.
Only
robot.
one independent. So.
Independent.
But in the future, or actually, our research robots are also running in this building, along with that delivery robot. So, in some stage, we have to implement such kind of, fleet management system. Just for traffic control kind of things will be needed in near future. Next year, okay.
Okay, great. Then let me tell you that in case that you need some training on this, so we are delivering some trainings about fleet management systems, and we have built in Barcelona. We have built a cafeteria. Full cafeteria, and then we have the robots that they are serving, so you have to learn how to coordinate them, how to program them, navigation, mapping, coordination, and all that. So in case that if you are not interested, just for the audience, okay, so I'm putting here the commercial for the commercial. That's okay. Okay, then what are other projects that you're working now?
Actually, we are currently working with external partners, including the Tokyo Land Corporation that is managing this building, and and also the Nikken Sekkei. They are architect company, global one, and working with them to build a robot-friendly environment. We are joint research with them.
Yes. Okay, that makes sense. So that goes also in the direction that you mentioned at the beginning of the podcast about the building, this building being built with the control of the elevators already implemented. So if I understand more or less, maybe some of your projects is about making the architecture robot friendly or something like that?
Sure, that's the part. The building, the city has a design to be robot friendly. To implement more robots into city and our life, social. So.
Yeah, I can imagine. Well, it's the same thing that we have done, for example, for the cars, right? For cars, we have made cities car friendly, right? So it will be in the same direction for robots. Okay, great. So, one final question is the tough one. So, what do you think about ROS being acquired by Google? So, any change in your company plans because of that you can share with us? I know not your secrets, but
Yeah. Well, this is my opinion,
Okay,
not
yeah, sure.
not representing the company or group's opinion. This is
Yes.
my personal,
Yes.
but personally, no change in our section's direction. No change.
Oh, okay.
But so the acquire of the ROS is kind of considering many contribution from Google to ROS and open source community, and they've already invested quite a lot into robotics technology. So kind of natural step for them, I guess.
Yes, I would like to have more questions about this subject because many implications. But that's the subject for another podcast. So I think that we learned a lot today about delivery robots, and especially the ones that your company, but they served as an example of real delivery robots and challenges and ideas and the problems and the successes and so on. So thank you very much for being at the podcast. Thank you very much.
Yeah, thank you, Ricardo-san. Thank you. Goodbye.
My pleasure. And that is all for today, ROS developers out there. So remember that if you want to learn more lessons from the experts, so you will have another episode next week here at the ROS Developers Podcast. See you and keep pushing your ROS learning.